All right. Um, so, as Matt said previously, we are going to talk a little bit about an overview of SQL. SQL is a broad and deep topic. We are going to touch on some of the basic tenets. So, first off, we can't talk about SQL without discussing relational databases. I'm sure this is not your first foray, but generally speaking, relational databases are an interconnected web of tables that are linked to one another. Um, Within these, data is organized into rows and columns, and every entity has many aspects linked to it, although all those aspects might not be stored in the same table. Every table has a database, or every table has keys. They can have a primary key, which is native to that table and is a unique identifier, and they can have foreign keys, which are unique identifiers from other tables, which link back. But given that we have all of these different tables, and we really wish it were all kind of united together, how do we muddle through these situations? What would it look like if we had a big single file with all of this information? Um, it would look really nasty. So in real life, these tables are collected by different people. If you're in sales, you're going to collect different sorts of information about your customers than if you are the marketing folks. If you are the people investigating sexual harassment claims, you're going to have different interests and thus collect different data. But some poor schmuck has to bring all of these tables together, create the database, and see what is overlapping in it. Where I worked, nobody made these databases. We just had a whole lot of tables. And when we first began hiring data scientists, they had to aggregate them and build the DBs. And they had to do it in a weird classified version that was similar to SQL but wasn't really SQL. So in real life, you're not going to be handed a nice, pretty diagram and fully updated databases. You're going to be handed something that's dirty and probably needs a lot of cleaning. So keep your eyes open. So as you might have suspected from the little spoiler article I sent out over the weekend, there are a lot of interesting ways to move money around. Some of them are legal and some of them are not. Some of them are easier to find than others. And in Afghanistan, they have a system called Hawala, and this is an ancient system. It's been around for many, many, many years, and the mum's the word. So they're not going to sit there and write down how much money you give them per se. And if they ever break trust, they go out of business. And traditionally, Afghanistan, Tajikistan, Uzbekistan are not great at financial auditing. So they prefer to put money, at least like Tehrik-i-Taliban in Pakistan, the TTP, and Afghan Taliban prefer to put their money in hawalas, which are informal rather than central banking systems. Some of this can be like money laundering, like literally laundromats are a great way to claim greater or less profits than you actually make because it's cash business. But sometimes they just do transfers, international transfers. The financiers might be in Saudi Arabia, but the money has to make it to Afghanistan. So if you are the UN and you're looking to bust up some of this money, how do you find it? So there are a couple of signs that really stand out to financial auditors. Oh, we'll talk about those here soon, but a lot of them have to do with bringing together information from a bunch of different tables. For example, does something that's in a different currency get withdrawn from a local bank? Does a transaction with exactly the same amount of money that was bought up in SIM cards appear in Iran 3 weeks later, down to the penny? These are some things that jump out. So if all of this information is kept by different organizations in different places, how do we gather all of this? So the first step is a court order. You have to ask the banks of Iran, the banks of Afghanistan, and all of these small business owners who might be doing hawala on the side to put forth their finances, and they have to, because they're purportedly law-abiding citizens and you don't want to give just cause. And then we can use SQL. We can make our database, and using SQL, we can grab the pieces that we need from all of the different tables, bring them together into a unified data set, and then the puzzle pieces can become clear to us. And you might say, like, we were using SQLite in our material. Why do we use SQLite? It's free. It's open source. That's the perfect reason to use SQLite, versus if you have to buy SQL Server and pay a licensing fee to Microsoft. Furthermore, SQL is a query language. It has specific applications to specific servers. Versus SQLite, you can use it on mobile devices. You can use it in, they used it in Game Boy Color, oddly enough. You can use SQLite anywhere at any time because it is a tiny and portable database management system. However, it does use SQL syntax, and a lot of people will just say they're using SQL to get the job done when actually it's SQLite. All right, so you remember I said before, if you're lucky, you'll get a diagram, but you usually won't. So this is what I'm referring to. It's called an ERD, Entity Relationship Diagram. And if your predecessors have done their work appropriately, they will document all of the rows, or rather all of the columns, more importantly, for this diagram, and how those columns relate to values in other tables. So you'll notice that there are, in every table, there's at least one variable that has an asterisk next to it, and that is the table's primary key. It is a unique identifier. And you'll also notice there are some weird symbols on the lines between the tables, and those will indicate one-to-one, one-to-many, many-to-many kind of relationships. And if you're wondering, well, which one means what, there you go. If you see zero or many, I don't like to mess with those kinds of things. I would go back and change it up once I figure it out. If you have a zero relationship, you probably don't need that feature in your data set anymore. That's how you get errors. All right. This PowerPoint is right there in the repo, so if you don't want to draw all of these symbols, feel free to grab it later. All right, so now that we know kind of what the shtick is, we're gonna have to bring together information from various tables, and then we're gonna have to look for some signs once we have that information together. So we talked about it a little bit before. Purchases abroad, conveniently $2,752.57, but Al-Qaeda guy went to the local store and bought like 350 SIM cards for exactly that amount a few days before. Magically, that money arrives in Iran to some guy. It's a little bit suspicious, but unless we have information from Iran and information from that gas station, we're not going to know that this happened. So any type of personal check, like nobody in my town accepts a personal check. Why would somebody in Tashkent accept a personal check from southern Afghanistan? Why would a guy be buying laundry detergent for $300 a bottle? It's kind of suspicious. Yeah, SIM cards. Anytime you buy more than like 2 SIM cards at a time, it's probably not going to a good place. And then let's see. Lots of cheap product being bought for more expensive, or lots of expensive product being bought on the cheap, because then you're wondering where's the rest of that money going. All right, we're feeling like we know kind of what are some red flags for money laundering. All right, now it's time for our practical application. So on the slide after this one, you will have an ERD given to you. There's no data associated with it yet. I think a big part of success with SQL is visualizing what you need and where you need to get it from. So this first activity, you guys are going to work together to figure out what you need and from where. And I'll leave it up on the screen. Then at the end, we're running a little bit late, so you guys will have 7 minutes to kind of work together, figure out what tables you need to pull stuff from and what variables you want. And then when we come back after 7 minutes, we will work together to plop it here in the table. We'll do it Pee-wee's Playhouse style. I'll point at a block. You guys will say, currency. We want that to be there. We'll pull it in. Or perhaps I will give mouse control to somebody. Given that we don't have a bunch of people in class, we're going to work together as a small group in the main room. And people at home, this is the point where I pause the recording, take a look at the next slide, and fill in your own chart of feature and tables of origin. We'll see you when we begin recording again.
All right, so switching gears a bit here, moving from a serious topic like illicit finance to an even more serious topic, Pokemon. We're going to try out some SQL commands and see how it all works firsthand. So can everyone see my screen here? Yes? Okay.
Yeah.
So for this, I have a database here. Hopefully everyone's at least a little familiar with Pokemon. It's a database, though, of various Pokemon, their moves, their different types, and their weaknesses. So here's kind of a simple diagram of the 4 different tables we have and how they interconnect. We have the Pokemon table, which has an ID, a name, genus, height, weight, and a type 1 and type 2. The type 1's like their primary type. We have a learned moves table, which has a Pokemon ID that connects with the ID in the Pokemon table. We have the move name, its power, its PP, which is how many times the Pokemon can use it per battle. We have the level at which the Pokemon learns it, and then we have the type ID. The type ID connects to the types table with the ID column, and the types table has also the identifier column, which is just a text representation of the ID. So say the ID is 4, that corresponds to water type Pokemon. So for identifier, you would get the string water. And then we have the weaknesses table. So if you know a thing or two about Pokemon, you know, for example, water type attacks against a fire type Pokemon will deal extra damage because the fire type Pokemon is weak to the water type attack. So in the weaknesses table, we have the attacking type, the defending type, and then the damage factor. The damage factor is 100 if there's no resistance or weakness. It's 200 if the defending type is weak to the attacking type, and it's 50 if the defending type resists the attacking type. So if the defending type's water, water resists fire, so if fire is the attacking type, the damage factor there would be 50. So hopefully that gives you an idea of how all those different variables work. So now we'll kind of go down here. You can feel free to follow along in your own notebook. So first of all, we need to import our libraries and connect to the database. So we need to import SQLite 3 and import pandas as PD. Then we're going to need our connection object, which we get from SQLite 3, dot connection capitalized. And then we pass in our database, which is pokedex.db. Then we also need what's known as a cursor, which basically is the workspace that we're using. So instead of modifying the table directly, it's kind of a temporary area where we're grabbing different columns from the tables. And we get that from the connection object .cursor. So if you go ahead and run that, you should have everything set up that you need. Give it a second here to load. All right.
Mine's just saying Pokedex not found.
You might want to check what folder you're in. It should be in the same folder as the repo. Is it working for everyone else?
Still getting the command going.
Just give a thumbs up when you got that first cell running, everyone. All right, Julia, it's good to go.
I have a question though, because in the work that I was doing in the whatchamacallit, the labs and in the actual sections, it was like dot connect. That's the same thing? right? Like instead of dot connection.
I think it might be. It might depend which version you're on too. They might have changed the naming around.
Okay.
So
In
everyone
the
else,
in the
go ahead.
documentation, cursor was also a bit more of a belabored process, but Matt kind of like streamlined it here.
All right, Beth is good. Brendan and Jacob, are you having any luck?
I got it going.
Okay. What about you, Brendan? Good? Okay. So we're going to start off and go through some of the different SQL commands you'll use. So the first one's select. It's the one you'll probably use the most because you basically need it for every SQL command. It does what it says. It selects certain data from the database. So to run a command, what you do is you take your cursor object and you do .execute. And then in the parentheses, for SQL commands, they have to be surrounded by 3 quotation marks like that. And so for formatting's sake, this is kind of how I set it up, just because SQL commands can become kind of messy. So I'll kind of space them out like that. And then we put our first command here, select. And for this question, we want a list of all the Pokemon names. So if we go to our database table here, we can see in the Pokemon table, there's just name. So we need to select name, and then you have to tell it what table you're selecting it from. So from Pokemon. And so that will execute it. But if we run just that, we'll just get a return of our cursor object. So to get an output from all that, we have to, on our cursor object, do cursor.fetchAll. And that will print out a list of all 150 Pokemon. And so this isn't very pretty. So what's easy to do is just kind of plug this right into a pandas data frame. And we can do that pretty easily. We just create our data frame object. So df equals pd.dataframe. And then just pass in that fetch all command. And then to set up the columns, because right now we would just get a table without the columns, so we would have to kind of know what they are. But we can set the columns by doing df.columns equals, and this is kind of a quicker way to do it. It's a list comprehension. You may or may not have seen these before in Python, but it's going to be x and the first element for x in cursor.description. And I can explain what this does more later, but basically it just grabs the column names for all the columns and sets them in our data frame. And then if we just display our data frame here, give me 1 second.
I think it's the quotation, not quotation, the parentheses after description.
Oh yeah, there we go. Okay, so there we have a data frame of all the Pokemon. It's a lot cleaner, easier to read, and easier to work with. So going forward, we can kind of just copy this code and modify it for all the other sections. It makes it really easy. So we'll move on to the next command here. It's where. So with where, it basically lets you narrow down what is returned from your SQL command. So for this example, we want to again get the names of all Pokemon, but we want only the ones that have water as their primary type or type 1. So we have the same command as before, but now we just add where type 1 equals water in quotation marks. And that should give us all the water Pokemon. All right, so you can see up here, it kind of just returns it in the order that it is in the database. So what if we want to get it back in a different order? Well, we can use order by. So order by will just order it by a certain column value. So for here, we want to get the names and the weights of each Pokemon and rank them from highest weight to lowest weight. So we're going to select name and weight from Pokemon. And then we're going to order by weight, and the default is to order ascending, so it would normally give it to us from lowest to highest. So we actually have to add this here, DESC, for descending. And if you go ahead and run that, it should give us the heaviest Pokemon first, all the way down to the lightest Pokemon. So that's kind of a long list. What if we only want like the top 10 heaviest or the top 5 heaviest? Well, that's where the limit command comes in. So for this, we actually want to look at height, and we want to find the top 10 or the top 5 tallest Pokemon. So we'll select name and height from Pokemon. Again, we'll order by height descending. And then all we do is add limit at the end and how many we want to get back. And that will give us the 5 tallest Pokemon. So now we start getting into some of the more complex commands. Group by kind of lets you aggregate columns. It's usually used when you want to find like an average value, a sum, or a count. So in this example, we want to get the types and the average weights and heights for each primary type, or type 1. So to do that, we're going to select type 1, and then we want the weight and the height, but we want the average of both of those. So what you can do is just add this around each one, and that will calculate the average weight and the average height. And then another trick, you can add a name to what this column will be by adding as afterwards. So we'll call that average weight. And then for this one, we'll do as average height from Pokemon. And if we just run this, we'll see that we just get one return. And this is actually the average weight and height of all the Pokemon. And then it just returns, I think, like the last type in the table, maybe. So to get it by type, we have to add group by type 1. And there we have the 13 different types, or 14, and the average weights and heights for all of them. And then from there, you could also, order by average weight. And now it's sorted from lightest to heaviest. And that's the nice thing about using this as here, to kind of give it a different name, so then you can reference it later on if you do like an order by. All right, and now on to join statements. These are the most aggravating part of SQL. They get really messy really fast, but they're also super critical, and you have to know how to use them. So we'll start off with a simple one. We just want to combine the tables to be able to have all the move names, their types, the text version, and their type ID. So if we look at our diagram here, can anybody tell me what 2 tables we would need to have the move name, the type name in text, and the type name's ID?
Learned moves and types.
Yep, that's right. So we know we need those 2 tables. So we'll go in here. First, we'll fill out what we need. So we need the move names are known as move, and then type in types is actually referred to as identifier to get the text version. So we have to put identifier here, and then we can just put ID because it will grab ID from types. And we're going to do from learned moves. And now to join it with the types table, we do join types, and we have to tell it what values to join it on. So we do on, and if we go back to our diagram here, the 2 connecting values are type ID in learned moves and ID in types. So type ID equals ID. And if we run that, that should give us all the moves, their types as text, and their type IDs. Just by a show of hands, is everyone doing good with what we're doing so far? Thumbs up if yes. Good. Okay. So now we're going to try to combine these methods. The first challenge is to find the 2 Pokemon types with the least weaknesses. So for this, I'm going to kind of do the coding, and I'd like for someone or a couple people to kind of lead me and try to tell me how to do this, if you can. So I'll go ahead and put the boilerplate code here. And if someone wants to start, what's the first thing I should do?
Pass in what you want to select,
Okay, and what's that?
the types.
Okay, so just type, or
Type.
let's say I want the text version of the type.
Identifiers.
Yep. Okay, and what else do I need?
Looks like you want to count the number of weaknesses.
Yep, so for now we'll call it number weaknesses. And this is actually another aggregate function. It's called count. So you can actually do this as, and so what should we count to find the number of weaknesses? Any ideas?
All of them.
All of what?
All of the weaknesses.
Okay, but what column in our database should I count?
Damage factor?
Close. You're in the right table. We do have to use damage factor later on.
Mm.
So if I'm looking at all the defending Pokemon, what else do I have to look at to know if they're weak to something?
The attacking type and the damage factor.
Yes, so I have to actually count the attacking type here. Okay, so those are the correct things I need to select. From what table should I select these?
From
From the weaknesses?
Yep. So weaknesses. Now I need to do a join. And what was the other table? I need to join types. And what values should I join the two tables on?
ID and defending type.
Yes. So ID equals defending type. All right, so now what's the condition I need to meet to signify there's a weakness?
Oh, where a damage factor is greater than
50?
So 50 is when it's resistant, 100 is when it's neutral, and then above 100 is when it's weak.
so greater than 100.
Yep. It's greater than 100. Okay, and now do I need to order this somehow? How do I get the ones with the most number of weaknesses?
Order by count of attacking type.
Yep, and because I changed the name to num weaknesses, I can just use that here.
Yeah.
Okay, and how many values should I be getting back from this?
2.
2, so limit 2. So if I run this, does everyone think it'll work? Juliet says hopefully.
Yes, because we didn't put descending on order by, right? So it should give us the lowest two values.
It looks like you need to add the by after order.
Good catch. Okay, we'll go ahead and run this and see what happens. So we got a table of 1 value with just normal type and 46 total weaknesses. That seems a little wrong. So does anybody have any idea what we're missing?
The group by.
Yep.
You want to
So where
group
should that
by
go?
before the order? No, after the order?
It's before the order. So
Okay.
group by what?
Identifiers?
All right, and that's the correct answer. The two types with the least number of weaknesses are electric and normal, and they both have one weak. So good job there. Just on a scale of 1 to 10, everyone, how comfortable were you with that activity, real quick? 7, 6. Do you think you could do problems like this right now? By yourself? Yes?
Yeah.
Okay, you kind of have to say yes. Because now we're going to go into an activity. I do actually have a bit more down here on inserting values into tables and adding tables. And then I also have a very hard bonus challenge at the end that I'm going to give you guys as homework to do. It's really fun, and it's pretty helpful to be able to do it. But for our activity, we're actually going to tackle these next two problems. So we're going to kind of pause the recording here in a minute and have everyone kind of work together out loud and see if you can solve these. The two problems are: find the top 5 Pokemon having the highest variety of different move types, and get the names of all the Pokemon who learn a move that's super effective against water type Pokemon, and also include the name of one of those moves that the Pokemon learns. All right, so we're gonna go ahead and pause the recording here for the people at home and go ahead and start.